Hello everyone, in this tutorial we're going to use ChatGPT to solve some simple civil engineering problems. So in this case we assume that we're going to analyze and determine the bending and shear force of a simple supported beam. Let's suppose the beam is 8 meter length and it has a cross section of 0.5. Let me make it because the first gave deep, and that should be 5. And we also can make it say deep and also the weight. And the material is concrete, which has a 30,000 megapascal modular velocity, and a distributed load is 20 kilometer per meter. And the boundary condition is plane and roller in both sides. So we need to, and ChatGPT cannot draw something in the inside of the module, but you can use some other language programming to request a code, and there should be some drawing and graphical visualization. Now what we're going to do is, the first thing I want to ask ChatGPT to tell me about the determine the bending moment and shear force. So I already have here, and I'm going to paste it. Just you can enter and it will tell you to determine the bending moment and shear force in beam. You can follow these steps. So the first thing is you should identify the beam type and loading condition. That's the second is draw the force body diagram and also calculate the reaction, calculate the shear force, and calculate the bending moment, and plus shear force and bending moment, check the criteria of point these things. So it's 7 steps that you should follow, and then you can write for your manually work this thing. Now we have understand how many steps we should take to solve this problem. Now the second thing is we want to give an example. We want to ask to solve an example for us, and the program will automatically do for us. So you see here giving this example, and the program quickly specify our beam properties and say the length is 8 meter, the cross section is this one. I should make a small changes here. That should be 0.5 and 0.8, which is the depth. Here you can see program will and submit again, and you can edit anytime you want. And you automatically calculate the reaction force in the first step, and the reaction force is 113 both sides, which we divide by 2, and it's become 180 kilonewtons. And we're gonna draw the shear force, and it's the shear force, and giving the bending moment, plot the shear force, bending moment, giving. Now what we're gonna do is I'm gonna ask it to write a Python code for us to draw the graph. Copy. Sometimes the program will do mistake, but you must be able to understand. And you can see the first thing is you must have a matplot to plot this, and then you should have Python in your program computer. And here is the program. Let me see, copy it, and I have a Python with notepad editor, so I'm gonna save it and just going to Control-Shift-A is my Python program, and you can see the graph is here. So the first thing is called shear force diagram, and you can see the shear force diagram is going to be in 0 displacement, so we have 18, so other side it should be minus 18. So that's the graph. But yeah, you can see here that you can see here 0 0 and positive if in case if you're putting A and B, so or right and left side is B. Okay, this is okay and accurate, and the bending moment is also accurate. So you can see in a 0 is 0 and 8 meter, which is the other side of the beam, is okay, but the maximum is 100,000 newtons times meter. And the last one is the displacement. So you can see the displacement, as we know, is in the maximum area, which is almost in this point 8.8 meters. Sorry, not 8 point, it's you have one minus, it's about 8.8 millimeters, 0.85 millimeters. And you also can tell the program to the displacement should give us in millimeter. Let me ask, give the displacement in mm. The program automatically will actually rewrite the code, and this time you will see that displacement will be in millimeter. Yeah, copy, and we want to substitute with the previous code, and we're going to rerun. So the program is already running. it's not running because the previous one was open. So now I'm gonna rerun it. Let's call the title displacement diagram. Here is some small error, and it said syntax error, invalid syntax. If I want to solve this using the ChatGPT, just copy this one, and I'm gonna say here, just again, copy this from here to here, copy and paste it here. It's called apologies for the confusion, and it will give us the plot again. So copy and replaced. Now the error is also finished, and now you can see the displacement is a base millimeter, so it's less than 1 millimeter, and moment diagram is also about 160,000 or 160 kilonewton times meter, and the reaction force is minus 80 kilonewton one side and 80 one side, which is correct. And this was a sample example how to use ChatGPT using civil engineering program. So in the future we will work some complex and also some more advanced problem to solve using ChatGPT. So okay, if you have any question, please put in a comment and point time to answer you. See you next time. Hello everyone, this is the second tutorial of using ChatGPT how to solve the civil engineering problem. So in previous one we gave a simple example how to determine the bending shear force, and this tutorial, which is a little advanced, which we were discussing on the beam vibration. So beam vibration is actually a very complex phenomenon. You can read some books and know about this, but we also list ChatGPT give us some examples, some information. This is applicable in bridge and also in structural engineering. So the first thing is I'm going to copy this. You also can write this question directly to the ChatGPT, and I said what's beam vibration, in case if you do some mistake or some spelling, then program will detect the misspelling and say, oh, what's beam vibration? So beam vibration refers to the mechanical oscillation or movement of the beam, which structural element that primarily resist loads. So this is some information. It's come to the vibration, free vibration, and this occurs when a beam is displaced from the equilibrium position. Actually, we have a kind of test, which one test is called force based test, and a second is called displacement based test. We will take a beam, and then we will aid with hammer, and then we will see the oscillation of that beam, until the beam will be suppressed because of some sort of damping that the material in the material exists. And the second is going to free vibration and force vibration and resonance, also a phenomenon that the natural period of the beam and also natural frequency of that force is matched together. Then there will be some resonance, which is displacement goes almost infinite, and then there will be some sort of collapse and damage to the structure. And here's some information. So now in the second part, I'm going to give an example. In the example, I have given, let's see, a 10 kilonewton or just 1 kilonewton with a force of 1 kilonewton. We want to aid the beam in the mid span. So you can actually point out in the 0 point or in the 1 meter length or any area you want, and then you should say what kind of support has this beam. So I'm going to call simple supported. So when you say simple supported, the program will determine one side is roller, one is beam, and you must determine the beam is made of a steel section, I section, which has this geometry, and still modular velocity is 200,000 megapascal. So I copy this one and paste it in the continuous of this, that the program will understand what is above of this. So some okay, I'm gonna call and then the program will calculate for us the natural frequency for us. It's called the formula for the natural frequency if, and then also the constrained load and everything they will give us for us. The first thing, the program will give the natural frequency, first smooth vibration, and then the mass. It will calculate the mass, and then it will determine the area of the section, and then something is not giving, the density is not giving, the program will assume this one because they already defined here, and then you're giving the first natural frequency is 0.27 hertz, and we determine the natural frequency. And what we're going to do is we want to determine when the external force is applied to that beam, and we want to see the vibration. So in here, in the second question called draw the displacement and acceleration of the beam during 10 seconds after the force 8, use Python. You can change the question in different scenario, but I made like this same. Now you can see here it's asking okay, and you should have Python in your computer, and also you should have matplot, and it's going to continue, and here is the final one, and I'm going to copy this code, and you can read the code and understand. So I already have the Python and also matplot in my computer. I'm going to call save, and then going to, but remember now I already saved this as a Python file. In case you copy here, it's not the same, that you must come to the save as or save. You find a location and you must determine the Python extension Python, and you give the name called beam vibration, and now you're going to save it, and I'm going to run this code. So now you can see this is the first one is the displacement using meter, and the second one is acceleration. So when we add the beam in the metal side, so that we will actually measure the displacement and acceleration in that point, and because the cross section is same, you can measure in any point the displacement and vibration. So you can solve a very complex problem using this ChatGPT program, and then you can save it and for your reference and also for your work. So that's all for this tutorial. If you have any question, please put in the comment and I'll find an answer. Hello everyone, this is another tutorial from the series of ChatGPT to solve civil engineering problem. In this problem, we're also discussing a fundamental problem which is called pendulum motion. This is actually in physics and also some other mechanical device, and it's obvious that we are familiar with the pendulum motion. And today we're going to ask ChatGPT or AI to give us what's pendulum motion, and then we will ask them to give us example in case if we have one pendulum which has a length of 1 meter, and here is a max. We're going to aim. It's a little bad. Aim, and so this is the vertical direction, and this is the fixed boundary condition, and the stiffness of this cable is actually negligible, it's very zero. And then we have the theta. In case of particular problem, then you must give that theta, which is going to displace the mass based on this theta, and then you will get the displacement of this pendulum. And also it generate in case there is no fraction in air, and then you will get movement or a free movement or motion. It's very popular in some watch or clock, and such kind of pendulum exists, and it's always freely moving because there's no fraction in air. So we jump to the ChatGPT and copy, and here we're going to paste, Control V and enter, and you will see that the information is quite wide, and it gives you pendulum motion refers to the movement of an object that's swinging back and forth around a fixed point due to the force of gravity. So the object in this motion is called a pendulum. A pendulum typically consists of a mass known as a ball or suspended from a fixed point by a rod or a string. So this is something, and then we have to give the motion pendulum follow some important principle. Let's go period. The time taking for one complete swing, we can also determine this one, and also we have amplitude, which is the displaced point from the gravity point, and also frequency of that pendulum. So now here is some definition you can read and understand, And now we are going to the second part of the question. We want to ask that ChatGPT to give us an example. Give an example of pendulum and determine the displacement of pendulum at time of 2 seconds when the length L equal m 1 meter and the m, which is equal mass, is 500 grams. So remember, the program will automatically understand in case previously you have given the pendulum. So, and also you can specify the theta, which is the displaced. Here you write in the program, surely consider an example of simple pendulum with a length of L 1 meter and a mass of 500 grams. We will determine the displacement of pendulum to a second after it is released from its initial position. So first we need to find the period of pendulum. So we will use this equation, T equal to 2P times the square root of L divided by G. So then we have the G is this one, and we have determined that T, the period is 2.006. Now that we have the period of the pendulum, we can find it is angular frequency. Now we're using this equation, and the good thing is the ChatGPT provide all the equation for you, and then you will get the natural frequency, the angular frequency 3.133 radian per second, and then now next let's find the angular displacement at pendulum of the pendulum at 2 seconds. Now we will determine this one, theta t, theta 0 is, which is the initial boundary condition, which is going to be 0, and a cosine theta, and then we will, where the theta is initial angular, then put it to 0, so this will be 0, and now the theta 2, theta at 2 second, so this will be almost 0 radian. So at 2 displacement, the pendulum is released, so that the angle is approximately 0 radian. So because of the mass of the pendulum and the length, so the displacement in this theta is almost 0. In case if you change it, let's change to 1 second or 1 second, and you can see some data. So in the 0 second is also actually is almost 0, which is in the release time. So I'm going to increase it to about this 10 second. So and yes, now here is you can see the displacement. If you come to here, that this theta, when it is the displacement from that point, from this point to the vertical point, is actually this region, approximately 60.15 degrees. So the displacement is that one. Now we're gonna ask the program or the ChatGPT to write an animation code and draw that displacement graph within at least 20 seconds. Use MATLAB. So in this case, if you have a MATLAB program, and ChatGPT can provide you a simple code to draw the animation and also draw the displacement graph. So we're gonna ask him write animation. Not sure. Here is some information. Save this code in MATLAB and run the function, this one. Or I can copy this one, and here is my MATLAB program is open. I'm gonna paste it, and I'm gonna save it. So you should give a name, save, and then you can run here, or you can just press this command, and you can see here is the pendulum animation. So this is the point, which is 0, and the height is -1, which is hanging down, and the displacement is to this point to this point. In case if we measure that the displacement here, then it will be -1, +1, or no. Here is about 0.5 m, 0.5 m, the positive and negative. But it will be, because there's no fraction, we didn't define sort of damping fraction on the material or the cable, so it will be continued freely until we want to stop it. So now it's stop, and so we can stop it. Yeah, we stop, and now the program after the because we need to keep it 20 seconds, we asked to give us the displacement graph within 20 seconds. So it will actually record until 20 seconds, and it will provide us a displacement curve for us. Now here is the displacement curve, which is 0.6 minus and positive, but it's using radian. So this is the graph. You can actually save this graph, and also you can change anything you want. And in case if you want to improve the MATLAB code, you can manipulate this code and using or changing the mass, and also changing the length of the string, or even you changing the theta. Also the time steps you can change. In case if you want to be faster, you can actually make it like 10 in case. And there is some other things. You can see the position in case it's okay. It's a fixed position, which is giving to draw the animation. And also you can change the grid if you want to change to the millimeter. These things also, and the program will do for you. Now this was a very important part of this ChatGPT. We can solve some much more advanced and also complex. So this is the end of the tutorial. If you have any question, please put in the comment, and we'll find time to answer you. See you next time. Hello everyone, and welcome to the fourth tutorial on how to use ChatGPT to solve civil engineering problems. In previous, we discussed some basic and also some advanced topics. In this topic, we're going to use ChatGPT to give us some information on spring dashboard model. So spring dashboard model is very popular in civil engineering. We use in different part of the structural design and structural analysis, and it's also a single degree of freedom model. So this is an example. You can see we have a spring which has a stiffness of the spring, and we also have some masses hanging on the spring, and this spring has some stiffness. It's in the bottom. It can be actually parallel to this in this device here, and you can see here is like this dashboard. So it should be here as well, and it's called C, or damping constant, and it's a spring and it's a mass. So now we want to ask the ChatGPT to give some information about this spring, and then we want to model that spring dashboard using Python, and we consider different cases for this model. So let's jump to the program, and I'm gonna copy this. Copy what's the spring dashboard. Just you also can write here, and let me write it called what is spring dashboard, and here is something. Spring damper, actually it's called a spring damper system, simply massive spring damper system. It's classical mechanical system used to model the behavior of certain physical system. It's very popular actually, and the thing is that it's a first order partial differential equation, and you can see, and there's the different numerical solution, and also some other technique to solve this equation. Now what we're going to do is we want to copy this one. It's called model the spring dashboard using Python. Copy, and we're gonna come here, and again let's paste it here, and we should understand that the model, the mathematical model is this one, and the program will solve this one for us. So we're gonna ask here, and it's called to model the spring dashboard Python. You can use the numerical integration method. Yes, for the partial differential equation, we need to integrate this one method, and the second is arrange with Quota method, and you can see here is the generated code. So we're going to copy. We have here we have a notepad editor which is compiled with Python programming, and we're going to run this model, and you can see what's going on. Here is, and in this program automatically it will solve for us the displacement velocity, which is two variable. So now you can interpret the code here, and for the solving some scientific calculation, you need to have the numpy, and then also you have matplot for the plot. And here is the things we have: some variable, mass, stiffness, and the damping ratio, and also force. You can apply some force in the end of the here's an example of the mass. You can see here, which the YT should be a force, or this force, the YT displacement initial conversion, and the FET is the force applying here, or the mass is stretched and then release, and then it's going to back forward. And we can see the code is here, and then the numerical integration using Euler method is here, and then the mass is 1 kg, and you can change this, the mass be 5 kg, and you can put it 0.5 kg, and the spring constant is 10 Newton per meter, and the damping coefficient is actually here written about 0.5, and you can change it as you wish. So let's suppose it should be 25, half of this, and then we want to increase. So now here is called initial displacement. It means the mass is this mass is actually displaced by 0.5 meter. So in case if I wanna increase this, yeah, here is 0.5 here, and I'm gonna increase it by 0.1 to 0.5. 0.5, which is 50 centimeters in stretching, that it is. And the initial velocity in that point is 0. And now we have the time, total time, which is going to measure the displacement velocity after we displaced about 0.5 meter. So it's going to be 50 seconds, and the time step is okay. And so if we're gonna give a smooth curve, give a small step time. And the other thing is the same. So we're gonna rerun this model, and yeah, you can see here we increase the total time is 50, and we also stretch to 0.50 meter. Now you can see the velocity and also the displacement. Now for the last part, we come back to this here, and I'm going to say consider 3 cases, which is 5%, 10%, 50%, 20% damping, over damping, and then damping. And the program will automatically understand that this scenario, and it will rewrite for you a new code, and you can get the result. Now we can see here the code is generated. We also can consider the mass, and we can give the mass for us. Like let's say the mass should be, we can say where the mass or m equal 5 kg, and the first displacement that you can say, and the initial displacement is 0.5 meter. In case if you do spelling error, so it will fix for you. And now we're going to resubmit. Let's say submit, and the program said okay. You can give actually anything that you want, and the ChatGPT has such ability to provide for you a very accurate result. But you should know the basic of these things. And you can see here the previous was 10, and it's increased to 100. Even we can give the spring constant or the spring stiffness K. So now the code is generated. I'm going to copy this code again, and Control A and Control V, and just going to run it. And you can see here is the entire model. And the first is called undamped. Undamped is here, which is not going to stop until 10 seconds. And the second is 5% here, blue, blue after that, and the 10% yellow one here, and the green one, and the red one is going to stop to 10 seconds. And the last one is this one is called purple or overdamped. So we're gonna stretch here and release, and slowly it will, after like 1.5 seconds, it will be stopping. That 0 displacement. So this is called overdamped. Now you can save this as you wish anywhere, and then you can actually manipulate this data, and you can change. So this is the end of the tutorial. If you have any question, please put in the comment and we'll find time to answer you. Thank you. See you next time.